So I'm going to talk about APIs and really kind of walk through building a very simple API built on top of Node and MongoDB. And first, I kind of wanted to get a show of hands. How many people in here have built an API before? Okay, all right. So I'll run through a little bit of stuff in the beginning, and we'll get to the interesting pieces. And if we have extra time at the end, I have a couple things that I'll show off too. So APIs are cool. Node is very cool. Mongo is pretty cool too. So all of them combine, and we get like super coolness. You know, Doctor Who bow tie kind of cool. And you know, we all know what an API is. So basically, we use APIs to set a set of requirements and govern how we talk to and from different services, and they've given us a very good way to decouple the kind of the computing piece and the business logic from our UI and the different UIs that we now have to manage in a very digital first, mobile first. You know, you have so many different ways you can experience applications. APIs are a really big piece of what and why we do this stuff. You know, they let us build applications faster. They let us build front ends faster, mobile applications. This is really something as we look towards the future on what and why we should really look at using APIs and every chance we get. I'm going to talk a little bit about designing an API first, and some of the very high-level things that we think about both at Modulus and Progress when creating an API, and what I think is very important for the longevity and the goodness of creating APIs. And I got a list right here. Everyone loves lists. So plan it out. So plan it out really just means think about the purpose of this API. How big is it? Do you want it to be? What do you want it to encompass? What business solution is it a business problem is it solving? For today, we're gonna look at a very simple problem that we're trying to solve and what the API is built for. HTTP. I'm a huge fan of RESTful HTTP APIs. You know, JSON-based is my favorite. You can choose your format and that you'd prefer, but really speaking, HTTP is extremely important. And my view of the APIs, for the most part, web-based APIs. Now, if we think of APIs in a general sense, you know, the kernel of our operating system has an API that we work with. I'm talking about web for the most part here, and managing web APIs. Get, put, post, delete. You know, the typical things that we need to do are those CRUD operations, and they're made. Those HTTP methods are made directly for this kind of resource management and manipulation. Documentation. It's something us as developers hate doing, but when creating and designing and putting a public API, especially out into the wild, documentation is a massive undertaking. And my view has slowly turned to, I'd like to document first and think about how we look at the API from a planning level, even at the documentation. And I'm going to show off just one tool that I've used in the past for kind of doing the documentation thing. Think about version. So when we're looking at APIs from great big companies like Twitter and Facebook, Facebook has not been particularly good at maintaining a consistent API across its a consistent manner across all of its APIs, especially if you were trying to do things a few years back and now you're trying to do stuff with Facebook APIs. They have changed rapidly. On the other end, Twitter has been very good about versioning their APIs and how you get to those APIs with versioning. There's a lot of different ways to think about versioning an API. A popular one is changing the URL to include the version, so /v1 / the resource you're accessing. Another one is including a header inside of the request that you can change the version of the API that you're requesting. Security is a great big thing that we have to think about when not only when we're putting something out in the public, but anytime inside of our enterprise and how we access that. So that means both authentication and authorization on the different resources. So how do you manage those different pieces? There's a lot of different methods there. I'm not going to dive into that one because that one gets really deep really fast, and everyone ends up arguing on whether we should use OAuth 1, 2, or anything else. HTTP status codes, this is just a simple, remember that they're there, remember that they have a purpose, and when you're returning assets and responses from requests, try to include the correct HTTP status. And I do break that rule in my demo, so I'm sorry. Return consistent errors. This has been a big one, especially if you're building enterprise applications and multiple groups are going to be using these. Define that error format very early on and make sure that you always return a consistent error, no matter whether that's a code, how do you define your codes, all of those pieces. We've seen that vary even at the Node.js level. They've really worked over the last couple of years is defining what that consistent even error codes are and putting those out there. And the last one's just kind of a maintenance thing is if you're thinking about a large set of data and you're going to put an API around a large set of data, paging that data and paginating that data and limiting the results is a good way to do that. And there's a lot of different methods. Again, you can return the link for the next set of results in there. So there's a lot of different ways to do that stuff. From the documentation standpoint, I've been a pretty big fan of a tool called Apiary recently, and it allows you to basically define your API as a blueprint, they call it, but it's really a documentation standard for defining what the API should look like, what the request should be, what the response should be, and then what it'll do is it gives you the tools to put this in a format that you can then mock up a test API. You can test against that that blueprint. So it's a great way to basically set the base of what you think that API should look like, and really when you start going to do some work, what and how it reacts to requests and responses. So I'm going to jump into code. So I'm going to get to work, and I'm going to kind of walk through this thing, and we'll try not to screw it up too much along the way. And feel free to raise your hand, ask questions, be interactive, yell at things, throw things. Not anything too hard, but soft. So I'm going to jump out here. So the first thing we're going to do is we're actually going to go set up a Mongo database. I'm just going to use Modulus to do this. I don't even know what I just clicked. And hopefully the internet is still working pretty well here. So in the Modulus interface, this is easy. I'm just going to set it up just so I have it here. And here we're going to grab the connection string, and this is going to be what we're going to use inside of our application here. All right.
Excuse me, I'm just going to turn those lights down so you can see that.
Yeah, you can turn it down some. I got yelled at already for turning them down too much.
I think it's on or off.
All right. It's all right. I'd prefer it better for you than for the camera. So, okay. So the first thing we really are going to do is set up our application. And really what we're going to do today is build an API, very simple API here. But the API of our day today is just going to build an API that lets us track companies. We get a little bit of data about them. We get our basic CRUD operations. And what this is going to kind of look like is, if you look at the overall kind of general architecture here, if we're just going to say our user interface is going to be a mobile app, which it's going to be, our mobile app is going to talk to our backend. Our backend is a combination of Node.js stuff, which is in the blue, and then MongoDB, which is in the green, and they're in the back. And it's going to talk via REST APIs, and Express is going to talk to Mongoose, which is our kind of ORM that we're using inside of Node. And then that's going to be talking to MongoDB to kind of set up and manage all of this stuff. So our company, let's just define what a company is and what properties we want on our company. Very simple. Name, description, location, founded date, and stock ticker. Just kind of picked a few different things that would be interesting. And what basically I'm going to do is, this is just literally going to give us the base set of stuff that we're going to use. So I'm going to create a new project, npm init. So let's jump into here. Oh, that is not what I want. Gotta jump out of here. So if we're going to actually do this, we just we already have a little folder here. So let's just make a new one. npm init is a utility that npm ships with that basically will just set up our package.json. And in Node.js, package.json is the file that we use to find our dependencies. We kind of name our application, and it's what we use to install our dependencies and later on. Again, test app, we just kind of put in some stuff here. Take all the defaults, and we're good to go. So if I, so that's kind of what our package.json looks like. It's just a JSON app, a little bit of JSON that describes our application. We have no current dependencies. So we're going to install a couple dependencies. So I'm going to show you, you can see down here, npm I, short for install, express, --se. So we've found that inside of our company, at least, packages and their versioning just cannot be trusted to follow semantic versioning. So we pretty much exclusively always put the exact version of the package we install into the package.json. And then we periodically go and test the latest versions of our big packages that we're using. So this is going to install, express, and update the package.json to include the specific version that we installed. So of course things break. It's live. We'll do the thing that always works. Okay, so it's going to install Express, specific version, and then I'll show you what it's updated the package.json to look like. So you can see here, it's put the specific version of the package and the package.json of Express that we're going to use. So I'm just going to install these other two. Probably have to. this is when I jump to the one that already exists. Okay. So in this version, we've already installed our modules. So if I look at the package.json here, you can see that we have all three of our modules that we're going to use. This is all we need. And so Express is our routing engine that we're going to use for our API. Mongoose, again, is our database kind of ORM layer. And body parser is just a module that's used by Express to parse JSON bodies as they're passed in to the actual application here. So if we look at, and I'll walk through this stuff kind of line by line here, and I'll make that bigger too. All right, I think that's mostly legible. So this is just the basic pieces of the Node.js application here. And this will all be up on GitHub, and I'll send it out to everybody. And we'll walk through this line by line and kind of walk through these different pieces. So what this does is this includes the correct things that we our correct modules. Easy. This is our database connection. It's going to connect to our database. It lets us know if there's an error or not. And then our Express app. Our Express app, again, is fairly simple and straightforward. We create our Express app. We're going to enable the JSON body parser. And then this we'll walk through in a second. But this is basically saying I'm going to use these routes out of a file from the routes folder and the company.js file. And we'll walk through that in a second. And then the last piece is just opening the app to listen on a specific port. The routes I'll touch in a second, but the first thing I wanted to show here is we took our model that we said, and we're using Mongoose as kind of this ORM. And what Mongoose allows us to do is just more easily work with the Mongo database and kind of a model-driven format. And what we do here is define our schema. Now, the thing you have to remember about MongoDB is it's a NoSQL database. And that means that whether we define a schema here or not, MongoDB doesn't particularly care if it has these fields or has more than these fields, or these fields, some of these fields don't exist. So we'll actually show a little bit of that later in the demonstration. And the last thing is just exporting it. And what this does is this is going to allow this model to be used in the rest of the application. So when we're looking at our REST API, I'm going to walk through these. But when we're looking at a REST API, the first thing we're going to want to do is potentially get all of our resources from the API, and that's done here. And this is a router based on Express. Let me move the screen down a little bit. So Express is doing our routing for our API again, and we created a new router, and we're adding a URL to that router. So you'll notice that this says router.get, and it actually has slash, where the actual URL is going to be slash company on the actual URL, and I'll show that right here. And that's this piece right here. What this is saying is this is going to be my base URL for all of these routes inside of that file. So all of my routes will be /company/ something else, and that's going to be just /company, and that's a get. This is going to be a post to /company. This is going to be a get to /company/ID, and a put, the update, and a delete. And for our get, we're just going to literally find all of the companies that we have available in the database. And I've preceded with a couple, and we'll add a few more. So in the MongoDB world, find is how we retrieve pieces out of MongoDB. And this is just a simple method we're going to call. Everything's asynchronous and Node, so we've got our callback functions everywhere. But this is going to return our error and the companies that it found. What this is doing, what this res.json is doing, is it's going to actually return the companies that we've got from the database in a JSON format from the request, and we'll see what that looks like. So post is going to take the body from the request that it came in. It's going to create a new company on our Mongoose model, and then again return that company that was created so we can verify. This should actually have a different status code than a 200. I broke my own rules. Get company by ID, you can kind of get the pattern here. We're going to get the parameter of the ID from this name here. We're going to find it by ID. We're going to find by ID where we pull the ID again. We take the body that was passed and we update the company. And Mongoose really does a lot of the heavy lifting. And this is one of the great things about Node is the number of modules out there to do all of these different pieces of heavy lifting enables us to have 45 lines and a basic API that we can create, update, retrieve, and delete companies in our database here. So, and the last one is a remove here. So if we take a look at this, this is that's most of the heavy lifting on our API. In order to test this, we actually need to jump out here and we'll run it. So all this is going to do is this is going to start up our application. It's going to start listening on port 3000, and connection successful says we've connected to our database. I'm a big fan of this tool called Postman, which is a Chrome extension for testing RESTful APIs. There's a lot of different options out there, but this one works for me. So, like I said, I preceded this database with a couple companies in here, and you can see them down here. One is Progress and one is Apple. This is just a simple get, and that's going through that router that we have over here. So it's going through this router, and it's just pulling back all of the companies that we have available. We can add a new company if we just change this to a post. And what we're going to do is, and we're going to include our content type. And what we're going to do here is pass the actual JSON for our company. I've got an example over here that we can use to really get going a little bit faster. So we can add a company here. We'll skip the description. We don't even care about a description. So this is going to start taking advantage of some of those things that MongoDB is allowing us. It's pretty close-ish. We'll just pick something here. And we'll just send it. So we can see here, this is the actual JSON that is in the MongoDB. So the nice thing is, we didn't have to put a description. It didn't whine about a description. With Mongoose, we have the capabilities to stop it along the way and say some of these things are required if you want to define some of those pieces. And we can also manipulate them before they go in and come out of. So the ORM gives us a lot of capabilities there. But that's one of the nice things. So if we go back over here, we'll go back to a get. We should see 3 companies in here. Now, that's interesting. That's great. We can delete one. We'll delete Microsoft here. first we'll grab Microsoft individually, and then we'll delete Microsoft here. And we can grab our companies again and just make sure that things are just working as intended. Okay, back to 2 companies. So we've got our API. We've got a basic API that's, we've got less than really 100 lines of code, and we've got a basic API built in Node and Mongo. That's fantastic. So now we've got this. So what are we going to do with it? Well, we should probably consume it somehow. And there's a lot of different options when we're consuming a project. And being at the Telerik conference and being here and all of the announcements going on and some really cool stuff, I decided to build a native script app that consumed this. So we have a very simple, and I mean extremely simple, native script app that takes our API and makes it usable. Like I said, there's a lot of different ways you can consume this. So in NativeScript, it's pretty simple inside of NativeScript to call a JSON API like this. This is the actual code, which NativeScript is built on top of Node, so it's going to look very familiar to our server-side code. So we're kind of, again, taking advantage of JavaScript everywhere, and that feels warm and fluffy to me. So we've got some JavaScript here that's going to pull our pieces here. And first of all, this is just what it's going to look like, and I'll spin it up here, and we'll kind of hold on. These screens don't want to work together. So we'll show what it looks like, and then I can walk through the code to kind of. So I'm just going to run it on the emulator here. I can plug in my phone and run it on my actual phone too, which could be an interesting thing. But so basically, what it just did was took a bunch of JavaScript code and some XML code and made an iOS app, and we're going to run it on the emulator here, and it's actually going to talk to my local API that we have here and show us the companies that we put in. So, and we've got to wait for the emulator. And the screen is just so small. Okay, so we've got our 2. And just to make sure that I'm not faking it, we're going to add another one. So we added Delta, and you'll notice that we're just adding company names here. So we'll go over here, and it worked. Thank you. We can see that Delta has been added to our list of companies. So we can imagine building out a little more complex form inside of our NativeScript app to put in more data and bring them in there. So let's actually do something a little interesting here, and let's add another company from this one, and Microsoft back. So we got Microsoft, and I got to actually reload. I'm sorry, I didn't quite get my real-time syncing in there, but we'll rerun this, and we should have Microsoft and Delta and our 2 previous ones. So this is, again, a very, very simple native script app that's running on an iOS simulator. These are native. This is the native list view inside of the iOS, which is going to be extremely, extremely performant. So what's the code look like for this? Well, I'm happy to say, again, it's really, really simple. I'm going to bring this down a little bit. So for this, we have some just basic setup code inside of the NativeScript application and some setup files. Most of it can be done in the command line. I won't walk directly through all of that. But basically, what this is saying is I'm going to use my company's module over here, right here, and I've got my, it's going to load this. So this is my interface. You can see here it handles some events and we'll show how those happen. And then it's got some data binding, and data binding is super nice. You know, coming from the .NET world and not having that in interface is really painful to not have that kind of stuff. So this is fantastic to have this kind of data binding right in there, and we'll kind of see how that's all updated on the back end. So the only other piece of this application, we can style it with CSS, not worried about that at the moment, is the actual code to do things. And again, pretty straightforward here. What we have is we have some observable data, and it's an array. That's going to be our companies. We also have the page that we're going to be able to update and get to and from. And then we have our event that we defined over on this side. We have two of them here. So you can see on page loaded is one, and then on a tap of the button, we're going to call the add function. So we can see those two here. On the page loaded, we're just going to get the page. We're going to set a little bit of data. We're going to update and set our companies in our list. And the last thing we're going to do is set some binding context here. Now it gets interesting because we can now just call our API that we've already built and pull those companies. And the great thing with the data binding is as we update our companies list, they're going to show up in our list in the native script app. And the last piece here is adding a company. And we can see here, again, it's fairly simple. We grab the page data, we get the company name off of our field. Again, we're using this ID here to pull that data out. We're going to push a new company into our observable array. And the reason I do this is because in my experience, it's always nice to update the UI before we go to and from the server, and then if something happens, we can remove it later. I don't take care of that case in this, but always like to keep the UI as refreshed as possible and feeling responsive as possible. So we set the data, we remove it from the name, and then we stop the input from being active. And the only other piece we really have to do here is make a request to our API that we've defined with post. So this shows it off very well. So we're going to hit this URL with a post with our right content type, and this is the body of our post, and we're just going to stringify the name of our company. And you can imagine we can include all of the other pieces here, and they'll be updated on the back end, and we handle errors, and we silently handle the response. What we would want to do probably is on the error, if there was an error that occurred and a new record wasn't put in, we'd remove that data from our local array just to make sure that we're staying consistent with the server side. But we silently handle the response because we don't need to update the user because they've already, feels like it's already happened. So between that, we now have both the API built in Node and Mongo, and we have the iOS app that pulls in and uses this data, and all with a couple hundred lines of code and a very simple all JavaScript kind of workflow. I have about 10 minutes left. I'm happy to answer questions now, but also I was going to show deploying the API to Modulus if we don't have too many questions right at this moment. Okay, I'm going to show that then. So the last piece is, how do we go take this? How do we go take this API that we built in Node and Mongo and put it out for a public URL? And the last piece is going to be creating a project inside of Modulus. So we're going to just create this test project. Choose Node as our technology. I'm gonna just make it the small one and choose region. Don't really care. We'll just go with whatever defaults to. And then I'm going to jump back in the UI and walk through this. So I'm going to have to log in and try to remember the login here. Okay, so we can list out the projects. We have the one project that doesn't have anything in it yet, and what we're going to do is we're going to deploy our project out there. So what it's doing right now, it's taking our project and it's going to read that package.json that we had built and actually install all the dependencies and then bundle all that together in order to be able to go take that and put it on a cloud server and run the application. So we're seeing a live stream of the build as it's happening on a server up in the cloud. So our build is done, and now what it's going to do is it's going to actually provision a container onto a server, take our application, put it in that container, and then run it. Once it's running, it'll let us know here in just a few seconds, and we're up and running. And if we're really lucky, this actually works. I have not tested this. Nope, I broke it. So let's see here. Live debugging. Oh, I see. And what did we miss? That's what we missed. And we'll deploy again. I'll go through the same steps. We'll give it a second here. But what it did was it broke because it's actually case sensitive on the naming of the module for the file. Again, rookie mistake. So a couple of things to think about as this is deploying out is, now we've got a basic API, but really it's just the base set of things. And authentication, again, is a big one. There's a module called Passport inside of Node that helps handle a bunch of different authentication mechanisms that you may want to use, whether it's OAuth or even authenticating to like a Telerik, a Twitter API or Facebook or something like that. It has kind of built-in management of that. And the other piece is testing, unit testing. Internally at Modulus, we use Mocha and Chai for our combination of unit testing our applications. And again, with APIs, you should be able to unit test them fairly well because we have fairly defined routes. We should have fairly defined actions on those routes, and they should be stateless if we're actually following the REST kind of mantra on that. And then let me see and make sure. See if this actually worked. Nope. All right, I broke it. I'm gonna have to play around with that. So, bad job of that one. But the idea is that we can deploy this out and run it up in the cloud and have our API available publicly for everybody to see, and we could deploy our documentation alongside of it. So we've got the documentation along with our API. And I'm going to stop there. Questions? Question?
I'm very new to Node.js.
Mm-hmm.
So if you didn't have native script, how else would you deploy this?
That's really up to you on the kind of UI you want to build. You could use the Telerik app builder. You could use the mobile platform. I've done both. I've done actually all of those and played around with using those.
Outside of Telerik?
You could use PhoneGap. It really depends on what the UI of your choice is. Objective-C, if you want to go native, it can be a web front end. So we build web front ends, and for our web front ends are like Backbone plus another Node app. So we have a Node front end app talking to our API. And then we have, like our mobile app is a native app that's talking to the same API. So those are kind of just two different UIs talking to and our CLI just talks via the same API. So they're all using the same API layer, but they're all talking from different channels.
Do you recommend
Loopback's not a bad mechanism for building some of that stuff. They're Strong Loop's very focused on right now on that API kind of management layer. Depends on how deep you want to go and what you got to end up with. It's one of those, no silver bullet, obviously, but yeah, I definitely recommend checking it out and taking a look at it. It's a good comment. He mentioned Loopback, which is from a company called Strong Loop, which helps basically generate a lot of this CRUD stuff, and you can do that pretty quickly, and they've got a nice UI for managing some of these pieces.
Does Modulus have, Loopback has their own like deployment thing that I've been messing around with. Does Modulus allow you to live reload, like if your app crashed for some reason? Will it,
Yeah,
yeah,
we automatically take care of reloading a crashed application. We actually have full notifications built in, so you can get anything from an email to a text message to a phone push notification on an application crash, but it will automatically reload the application, and then you get a bunch of different notifications on that, and you can actually auto scale across different regions and things too to handle as load increases.
Out of interest, I've never used MongoDB, but I see everything stored essentially in sort of like a JSON format.
Yes, it's called Bison is what the actual format that it's stored in. It's a binary JSON format is what it stores the actual data as.
Do you guys support stuff like field renaming?
I don't think it has it natively built in, and I could be wrong on that, but I don't think it has it natively built in. However, you can query based on whether a name exists on a record. So we could actually just pull out companies that have a name plus a description, for instance. So there's different ways of handling that specific scenario. Anything else? All right, then we'll end a couple minutes early. Thank you, everybody, for coming out.